Hello everyone. Good evening. I voice tayo ko ma'am. Hello. Ma'am, may voice tayo ron tayo biro.
Tayo, sir.
Oh, yeah, sure. Okay, ꯑꯩꯈꯣꯏꯒꯤ coaching B.Ed coachingꯒꯤ ꯃꯈꯥ ꯆꯠꯊꯔꯛꯄ ꯑꯣꯏꯅ ꯉꯁꯤ ꯑꯩꯈꯣꯏꯅ ꯅꯩꯅꯒꯗꯧꯔꯤꯕ ꯀꯩꯅꯣꯒꯤ ꯁꯕ ꯇꯣꯄꯤꯛꯁꯦ ꯑꯩꯈꯣꯏꯒꯤ ꯁꯕ ꯇꯣꯄꯤꯛ 6 ꯂꯩꯕ ꯃꯅꯨꯡꯗ ꯁꯥꯏꯟꯁ ꯑꯦꯟ ꯏꯟꯚꯥꯏꯔꯣꯟꯃꯦꯟꯒꯤ ꯁꯔꯨꯛꯇꯣ ꯉꯁꯤꯗꯩ ꯍꯧꯒꯗꯣꯏꯅꯦꯕꯀꯣ. ꯉꯁꯤꯒꯤ ꯇꯣꯄꯤꯛꯁꯤ ꯁꯥꯏꯟꯁ ꯑꯦꯟ ꯏꯟꯚꯥꯏꯔꯣꯟꯃꯦꯟꯒꯤꯗ ꯑꯩꯈꯣꯏꯅ ꯀꯦꯃꯤꯁꯇ꯭ꯔꯤꯒꯤ ꯁꯔꯨꯛ ꯍꯥꯏꯇꯥꯔꯦ. ꯁꯥꯏꯟꯁꯀꯤ ꯄꯥꯔꯠ ꯑꯃ ꯑꯣꯏꯔꯤꯕ ꯀꯦꯃꯤꯁꯇ꯭ꯔꯤꯒꯤ ꯁꯔꯨꯛꯁꯤꯗ ꯑꯩꯈꯣꯏꯅ ꯅꯩꯅꯒꯅꯤ. ꯁꯤꯒꯤ ꯀꯦꯃꯤꯁꯇ꯭ꯔꯤꯒꯤ ꯁꯔꯨꯛꯁꯤꯗ ꯑꯩꯈꯣꯏꯅ ꯇꯣꯄꯤꯛ ꯈꯔ ꯈꯪꯒꯠꯂꯦ. ꯁꯤꯗ ꯂꯩꯔꯤꯁꯦ ꯃꯦꯇꯔ ꯂꯩꯔꯦ, ꯁ꯭ꯇꯦꯠ ꯑꯣꯐ ꯃꯦꯇꯔ, ꯆꯦꯟꯖ ꯑꯣꯐ ꯁ꯭ꯇꯦꯠ, ꯑꯗꯨꯗꯒꯤ ꯐꯤꯖꯤꯀꯦꯜ ꯑꯦꯟ ꯀꯦꯃꯤꯀꯦꯜ ꯆꯦꯟꯖ, ꯑꯗꯨꯗꯒꯤ ꯀ꯭ꯂꯥꯁꯤꯐꯤꯀꯦꯁꯟ ꯑꯣꯐ ꯃꯦꯇꯔ, ꯑꯗꯨꯗꯒꯤ ꯏꯂꯤꯃꯦꯟꯠꯁ, ꯀꯝꯄꯥꯎꯟड्स ꯑꯦꯟड ꯃꯤꯛꯁꯆꯔꯁ ꯍꯥꯏꯔꯤꯕ, ꯑꯗꯨꯗꯒꯤ ꯑꯦꯇꯣꯝ ꯑꯦꯟड ꯃꯣꯂꯤꯀꯨꯜꯁ, ꯃꯣꯗꯔꯟ ꯄꯦꯔꯤꯌꯣꯗꯤꯛ ꯇꯦꯕꯜ, metals and non-metals, acid, base and salts, chemical in daily life ꯍꯥꯏꯔꯤꯕ ꯁꯤꯁꯤꯡꯁꯦ ꯀꯦꯃꯤꯁꯇ꯭ꯔꯤꯒꯤ ꯁꯔꯨꯛꯁꯤꯗ ꯑꯩꯈꯣꯏꯅ ꯅꯩꯅꯒꯅꯦꯕ. ꯐꯥꯔꯁꯇ ꯁ꯭ꯇꯦꯠ ꯑꯣꯐ ꯃꯦꯇꯔ. ꯑꯩꯈꯣꯏꯅ ꯀꯦꯃꯤꯁꯇ꯭ꯔꯤ ꯍꯥꯏꯔꯒꯗꯤ ꯑꯩꯈꯣꯏꯅ ꯂꯩꯔꯤꯕ ꯁꯔꯥꯎꯟꯗꯤꯡꯗ ꯂꯩꯔꯤꯕ ꯑꯦꯅꯤ ꯄꯣꯠꯁꯛ ꯑꯃꯒꯤ ꯃꯥꯒꯤ ꯄ꯭ꯔꯣꯄꯔꯇꯤꯁ, ꯀꯔꯝꯕ ꯀꯦꯃꯤꯀꯦꯜ ꯄ꯭ꯔꯣꯄꯔꯇꯤꯁ ꯅꯩꯅꯕꯗꯨꯕꯨ ꯀꯦꯃꯤꯁꯇ꯭ꯔꯤꯒꯤ ꯁꯔꯨꯛꯇ ꯆꯟꯗꯣꯏꯅꯤ. ꯑꯗꯨꯅ ꯑꯩꯈꯣꯏꯅ ꯃꯦꯇꯔ ꯍꯥꯏꯇꯥꯔꯒꯗꯤ ꯁꯤꯗ anything which has mass and occupy space is called matter ꯍꯥꯏꯔꯦ. ꯄꯣꯠꯁꯛ any mass and occupy, ꯃꯥꯒꯤ mass ꯂꯩꯔꯕ, occupy space occupy ꯇꯧ ꯇꯥꯔꯒꯗꯤ ꯃꯗꯨꯕꯨ ꯑꯩꯈꯣꯏꯅ matter ꯀꯧꯋꯦ ꯍꯥꯏ. ꯑꯦꯛꯖꯥꯝꯄꯜ ꯑꯣꯏꯅ book, pencil or water. ꯑꯗꯨꯗꯒꯤꯗꯤ ꯁꯤꯗ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ ꯂꯤꯕꯤꯡ ꯕꯤꯡꯁ ꯂꯩꯔꯤꯕꯁꯤꯡꯁꯦ ꯑꯩꯈꯣꯏꯅ ꯃꯦꯇꯔꯒꯤ ꯃꯅꯨꯡ ꯆꯜꯂꯤ. ꯑꯗꯨꯒ ꯁ꯭ꯇꯦꯠ ꯑꯣꯐ ꯃꯦꯇꯔ. ꯃꯦꯇꯔ ꯉꯁꯥꯏꯒꯤ ꯄꯣꯠꯁꯛ ꯃꯥꯁ ꯂꯩꯕ ꯁ꯭ꯄꯦꯁ ꯑꯣꯀꯨꯄꯥꯏ ꯇꯧꯕꯁꯤꯡꯗꯨ ꯀꯃꯥꯏꯅ ꯀꯔꯝꯕ ꯁ꯭ꯇꯦꯠꯇ ꯂꯩ ꯍꯥꯏ ꯇꯥꯔꯒꯗꯤ ꯁꯤꯗ ꯑꯩꯈꯣꯏꯅ 3 ꯐꯤꯖꯤꯀꯦꯜ ꯁ꯭ꯇꯦꯠꯁꯇ ꯂꯩ: ꯁꯣꯂꯤꯗ, ꯂꯤꯀ꯭ꯋꯤꯗ ꯑꯦꯟ ꯒ꯭ꯌꯥꯁ. ꯑꯣꯀꯦ, ꯁꯤꯗ ꯁꯤ ꯁꯨꯃꯥꯏꯅ ꯁꯣꯂꯤꯗ, ꯂꯤꯀ꯭ꯋꯤꯗ ꯑꯦꯟ ꯒ꯭ꯌꯥꯁ ꯀꯣ ꯁ꯭ꯇꯦꯠ, ꯃꯦꯇꯔ ꯑꯣꯐ ꯁ꯭ꯇꯦꯠꯁꯦ ꯑꯩꯈꯣꯏꯅ ꯑꯍꯨꯝ ꯊꯣꯛꯅ ꯂꯩ. ꯍꯥꯏꯔꯤꯕꯁꯤꯡꯁꯤ ꯀꯃꯥꯏꯅ ꯇꯧꯒꯦ ꯍꯥꯏꯔ ꯀꯥꯟꯗ ꯁꯤꯗ ꯂꯩꯔꯤꯕ ꯃꯣꯏꯒꯤ ꯁꯣꯂꯤꯗ, ꯂꯤꯀ꯭ꯋꯤꯗ ꯑꯦꯟ ꯒ꯭ꯌꯥꯁ. ꯁꯣꯂꯤꯗꯀꯤ ꯃꯥꯒꯤ ꯄ꯭ꯔꯣꯄꯔꯇꯤꯁ, ꯑꯗꯨꯗꯒꯤꯗꯤ ꯂꯤꯀ꯭ꯋꯤꯗꯀꯤ ꯄ꯭ꯔꯣꯄꯔꯇꯤꯁ, ꯑꯗꯨꯗꯒꯤ ꯒ꯭ꯌꯥꯁꯀꯤ ꯄ꯭ꯔꯣꯄꯔꯇꯤꯁ, ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯅ ꯃꯣꯏꯒꯤ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ ꯄ꯭ꯔꯣꯄꯔꯇꯤꯁ ꯂꯩꯅꯦꯕ. ꯑꯗꯨ ꯁꯤꯗ ꯂꯩꯔꯤꯕ ꯄꯥꯔꯇꯤꯀꯜꯁ, ꯁꯣꯂꯤꯗꯁꯤꯗ ꯀꯔꯝꯕ ꯁꯣꯂꯤꯗꯀꯤ ꯃꯥꯏ ꯄ꯭ꯔꯣꯄꯔꯇꯤꯁꯇ ꯍꯥꯏ ꯇꯥꯔꯒꯗꯤ ꯁꯤꯗ particles are held close together in the solid state ꯀꯣ. solid state ꯗꯗꯤ ꯃꯥꯒꯤ ꯄꯥꯔꯇꯤꯀꯜꯁꯤꯡꯁꯦ ꯂꯣꯏꯅ ꯌꯥꯝ ꯀ꯭ꯂꯣꯖ ꯑꯣꯏꯅ ꯂꯩꯅꯦꯕ. ꯑꯗꯨꯒ ꯂꯤꯀ꯭ꯋꯤꯗꯇꯗꯤ ꯑꯃꯨꯛ ꯃꯥꯒꯤ ꯂꯩꯔꯤꯕ ꯄꯥꯔꯇꯤꯀꯜ, ꯃꯥꯕꯨ ꯁꯥꯒꯠꯂꯤꯕ ꯃꯆꯥꯛꯁꯤꯡꯁꯦ close to each other but they can move around. ꯃꯣꯏꯁꯦ ꯃꯅꯨꯡꯗ ꯆꯠꯊꯣꯛ ꯆꯠꯁꯤꯟ ꯌꯥꯏꯑꯕ. ꯑꯗꯨꯒ ꯒ꯭ꯌꯥꯁꯀꯤ ꯁ꯭ꯇꯦꯠꯁꯤꯗ ꯂꯩꯕ ꯄꯣꯠꯁꯛꯁꯤꯡꯗꯤ particles are apart as compared to those present in solid and liquid state and their movement is easy and fast. ꯍꯥꯏꯕꯗꯤ ꯒ꯭ꯌꯥꯁꯇ ꯂꯩꯔꯤꯕ ꯄꯥꯔꯇꯤꯀꯜ, ꯃꯥꯒꯤ ꯄꯥꯔꯇꯤꯀꯜꯁꯤꯡꯗꯨꯗꯤ ꯆꯠꯊꯣꯛ ꯆꯠꯁꯤꯟ, ꯑꯗꯨꯗꯒꯤ ꯃꯅꯨꯡꯗ ꯂꯩꯔꯤꯕ ꯁ꯭ꯄꯦꯁꯇꯨ ꯍꯥꯡꯕꯅ ꯃꯔꯝ ꯑꯣꯏꯔꯀꯥꯟꯗ ꯃꯣꯏꯗꯤ ꯑꯃꯒ ꯑꯃꯒꯤ ꯏꯟꯇꯔꯦꯛꯁꯟꯗꯣ ꯌꯥꯝ ꯐꯣꯔꯁꯇꯣ ꯌꯥꯝ ꯂꯩꯇꯦꯕ. ꯃꯗꯨꯅ ꯃꯔꯝ ꯑꯣꯏꯔꯀꯥꯟꯗ ꯉꯁꯥꯏꯒꯤ ꯇꯣꯉꯥꯟ-ꯇꯣꯉꯥꯟꯕ solid, liquid, gas ꯁꯦ ꯃꯥꯒꯤ solid ꯀꯤꯗ ꯃꯥꯒꯤ property ꯗ solid has definite volume and definite shape. ꯑꯗꯨꯅ solid ꯀꯤ volume ꯑꯃ ꯂꯩꯖꯩ ꯃꯥꯒꯤ ꯑꯔꯨꯝꯕ ꯑꯃꯁꯨꯡ ꯃꯥꯒꯤ shape ꯇꯣꯉꯥꯟꯕ ꯃꯁꯛ ꯊꯣꯛꯄ shape ꯑꯃ ꯂꯩꯒꯅꯦꯕ. Liquid have definite volume. Liquid ꯀꯤꯗꯤ volume ꯂꯩꯒꯅꯤ ꯇꯧꯕꯇꯕꯨ ꯃꯥꯒꯤꯗꯤ shape ꯂꯩꯔꯣꯏ. Any container ꯑꯃꯗ ꯍꯥꯞꯄꯨꯕ ꯃꯇꯝꯗ ꯃꯥꯒꯤ ꯄꯣꯠꯁꯛꯇꯨꯒ ꯃꯥꯟꯅꯅ ꯃꯥꯒꯤ shape-ꯇꯨꯗ ꯂꯩꯒꯤꯅꯦꯕ. And gas have neither definite volume or definite shape. They completely occupy the space in the container in which they are placed. ꯃꯣꯏꯗꯤ neither ꯃꯣꯏꯒꯤ volume-ꯒ shape-ꯒ ꯂꯩꯔꯣꯏ ꯇꯧꯕꯇꯕꯨ ꯃꯣꯏꯗꯤ ꯃꯣꯏꯅ ꯍꯥꯞꯄꯨꯕ ꯄꯥꯇ꯭ꯔ ꯃꯣꯏꯅ ꯂꯩꯔꯤꯕꯗꯨꯒꯤ shape ꯃꯑꯣꯡ ꯑꯗꯨꯗꯒꯤꯗꯤ ꯑꯗꯨꯒꯤ ꯃꯑꯣꯡꯗ ꯑꯗꯨꯝ form ꯇꯧꯕ ꯉꯝꯃꯦꯕ. ꯍꯥꯏꯔꯤꯕ state ꯑꯍꯨꯝ ꯑꯁꯤ ꯑꯩꯈꯣꯏꯅ interconvertible by changing the condition of temperature and pressure. ꯍꯥꯏꯔꯤꯕ state ꯑꯍꯨꯝꯁꯦ ꯑꯩꯈꯣꯏꯅ ꯃꯥꯒꯤ form matter ꯃꯥꯒꯤ state ꯑꯃꯗꯒꯤ state ꯑꯃꯗ change ꯇꯧꯕ ꯌꯥꯏꯀꯣ. sida on heating, a solid usually changes to a liquid, and the liquid on further heating changes to gas or gas vapor. ꯍꯥꯏꯕꯗꯤ solidꯇ ꯂꯩꯔꯝꯕꯁꯤ liquidꯇ change ꯇꯧꯕ ꯌꯥꯏ. ꯉꯁꯥꯏꯒꯤ pressure heat ꯅꯠꯇ꯭ꯔꯒ pressure ꯄꯤꯁꯜꯂꯀꯥꯟꯗ ꯁꯤꯗꯅ ꯃꯔꯨꯑꯣꯏꯅ heat solidꯅ liquidꯇ ꯑꯣꯟꯕꯁꯤ heat ꯄꯤꯁꯜꯂ ꯇꯧꯕ ꯌꯥꯏ or liquidꯇꯒꯤ gas ꯑꯣꯟꯕꯁꯤ heat ꯄꯤꯁꯜꯂꯀꯥꯟꯗ ꯇꯧꯕ ꯌꯥꯏ. In the reverse process, gas ꯁꯤ ꯑꯃꯨꯛ ꯆꯞ ꯃꯥꯟꯅꯅ liquidꯇ ꯑꯃꯨꯛ compress ꯇꯧꯁꯟꯕ ꯑꯗꯨꯒ liquidꯁꯤꯅ ꯑꯃꯨꯛ further cooling ꯇꯧꯕ ꯃꯇꯝꯗ solidꯇ ꯑꯃꯨꯛ ꯑꯣꯟꯕ ꯌꯥꯏꯑꯕ. Matter is constantly experiencing both physical and chemical change. ꯍꯥꯏꯕꯗꯤ ꯉꯁꯥꯏ matter-ꯅ ꯑꯃꯗꯒꯤ any state ꯑꯃꯗꯒꯤ gas-ꯇꯒꯤ solid-ꯇꯒꯤ or liquid-ꯇꯒꯤ change ꯇꯧꯕ ꯃꯇꯝꯗ ꯃꯥꯒꯤ chemical ꯃꯥꯒꯤ ꯃꯥꯒꯤ ꯄꯣꯠꯆꯥꯛ ꯀꯃꯥꯏꯅ ꯁꯥꯕꯅꯣ ꯑꯗꯨꯗꯒꯤ physical ꯑꯗꯤ ꯃꯥꯒꯤ structure ꯃꯥꯒꯤ ꯃꯑꯣꯡ ꯃꯇꯧ ꯑꯗꯨꯝꯕꯁꯤꯡꯗꯣ ꯂꯣꯏꯅ change ꯇꯧꯏ. ꯑꯗꯨꯁꯤꯗ ꯑꯩꯈꯣꯏꯅ physical change ꯍꯥꯏꯔꯒꯗꯤ a physical change alter the form of a substance but does not change it to another substance. Physical change ꯍꯥꯏꯔꯒꯗꯤ only ꯃꯄꯥꯟ ꯊꯣꯡꯒꯤ ꯃꯁꯛꯇꯨꯡꯗꯪ ꯍꯣꯡꯕꯗꯣ ꯑꯗꯨ ꯃꯅꯨꯡꯒꯤ ꯂꯩꯔꯤꯕ ꯃꯥꯒꯤ component ꯑꯗꯨꯗꯤ ꯍꯣꯡꯗꯕꯗꯣ. It change shape or size, it dissolves and also change phases. ꯁꯨꯃꯥꯏꯅ ꯇꯧꯗꯅ any freeze ꯇꯧꯁꯟꯕ ꯅꯠꯇ꯭ꯔꯒ boil ꯇꯧꯊꯣꯛꯄ ꯅꯠꯇ꯭ꯔꯒ evaporate ꯇꯧꯕ ꯅꯠꯇ꯭ꯔꯒ condense ꯐꯝꯖꯤꯟꯕ ꯃꯇꯝꯗ change ꯇꯧꯏ ꯇꯧꯕꯇꯕꯨ ꯃꯥꯒꯤ ꯃꯅꯨꯡꯒꯤ ꯑꯣꯏꯕ chemical property ꯗꯨꯗꯤ change ꯇꯧꯗꯦ. Physical change occur when matter changes its property but not in ꯁꯤꯒꯤ chemical nature ꯁꯦ change ꯇꯧꯗꯦꯕ. Physical property ꯗ change ꯇꯧꯕꯗ ꯑꯩꯈꯣꯏꯅ ꯃꯥꯒꯤ ꯃꯆꯨ ꯍꯣꯡꯕ ꯑꯗꯩ shape ꯍꯣꯡꯕ size color odor volume mass weight and density ꯍꯥꯏꯔꯤꯕꯁꯤꯡꯁꯤꯗ change ꯇꯧꯕ ꯌꯥꯏ physical change ꯀꯤꯗꯤ. ꯑꯗꯨꯕꯨ ꯃꯥꯒꯤ chemical nature ꯗꯨꯗꯤ change ꯇꯧꯗꯕꯤꯗ ꯑꯗꯨꯝ ꯂꯩꯒꯅꯤ. Chemical change ꯍꯥꯏꯔꯒꯗꯤ chemical change are change matter undergo when it becomes new or different matter. ꯍꯥꯏꯕꯗꯤ ꯉꯁꯥꯏꯒꯤ ꯄꯣꯠ ꯑꯃ any pressure or temperature any ꯃꯉꯣꯟꯗ external force ꯑꯃ ꯄꯤꯁꯟꯕ ꯃꯇꯝꯗ ꯃꯥꯒꯤ ꯃꯑꯣꯡ ꯃꯁꯛ ꯍꯣꯡꯉꯛꯀꯅꯦꯕ chemical change ꯇꯗꯤ. sida when a substance undergoes a chemical change, it is changed into a different substance ꯑꯇꯣꯞꯄ ꯄꯣꯠꯁꯛ ꯑꯣꯏꯅ with different property. To identify a chemical change, we should look for such as color change, bubbling and fizzing, light production, smoke and presence of heat. ꯁꯤ ꯑꯩꯈꯣꯏꯅ physical chemical change ꯑꯃ ꯇꯧꯕ ꯃꯇꯝꯗ ꯍꯥꯏꯔꯤꯕꯁꯤꯡꯁꯦ ꯑꯩꯈꯣꯏꯅ ꯎꯕ ꯐꯪꯒꯅꯦꯕ. Examples of chemical change ꯑꯩꯈꯣꯏꯅ sugar dissolving in tea. ꯆꯥꯗ ꯑꯩꯈꯣꯏꯅ ꯆꯤꯅꯤ ꯍꯥꯞꯆꯤꯟꯕꯗꯣ. ꯆꯥꯗ ꯑꯩꯈꯣꯏꯅ ꯆꯤꯅꯤ ꯍꯥꯞꯆꯤꯟꯕ ꯃꯇꯝꯗ ꯆꯤꯅꯤ ꯂꯩꯔꯝꯕ ꯆꯤꯅꯤ ꯃꯄꯪꯗꯣ ꯑꯩꯈꯣꯏꯅ ꯏꯁꯤꯡꯗꯨꯗ ꯇꯨꯝꯃꯒ ꯃꯁꯛ ꯎꯈꯤꯗꯕꯗꯣ ꯑꯗꯨꯗꯨꯕꯨ ꯉꯁꯥꯏꯒꯤ chemical change ꯁꯤꯒꯤ ꯃꯅꯨꯡꯗ ꯆꯟꯗꯣꯏꯅꯤ. logs burning u bai thaba natragana burning water up by separating it into hydrogen and oxygen. When separation of water to hydrogen and oxygen tongan tongan magi composition to the breakdown tꯧꯈꯤꯕꯗꯣ ꯁꯤꯁꯤꯁꯨ chemical change ꯒꯤ phenomena ꯑꯃꯅꯦꯕ ꯑꯗꯨꯃꯥꯏꯅ ꯑꯩꯈꯣꯏ ꯁꯤꯗ change of state ꯀꯣ ꯁꯤꯗ ꯃꯈꯥꯗ ꯁꯣꯝꯗ ꯂꯩꯔꯤꯕ ꯐꯤꯒꯔ ꯁꯤꯗ solid liquid and gas ꯁꯤꯒꯤ solid ꯂꯩꯔꯝꯕ ꯑꯗꯨꯗꯒꯤ ꯁꯤꯒꯤ liquid and gas ꯉꯁꯥꯏꯒꯤ state of matter ꯗ ꯑꯍꯨꯝ ꯂꯩꯕꯁꯦ ꯁꯤꯁꯦ ꯑꯩꯈꯣꯏꯅ interchangeable ꯑꯣꯏꯌꯦꯕ solid tagi liquid onba liquid tagi solid onba ade solid tagi gas onba or gas tagi solid to onba sumaina magi circle de leba any state matter do akoina magi state to change to be yaba ada akoina sida sinaba tam jing hai tare sigi state of matter change to bada akoina sinaba tam jing da sida sublimation. Sublimation it is the change of solid state directly to gaseous state without going through liquid state. Sublimation ngasagi solid tagi gas ta directly change tawbudo adubuna sublimation. Deposition haragana it is the change of gaseous state directly to state solid state solid state without going through liquid state. Ngasagi gas tagi liquid ta halakpa na directly gas to solid ta akoina change tawrapadu akoina deposition and boiling is a bulk phenomena ko ngasagi sida leiba fusion sigi da yaudre boiling is a bulk phenomena particles from the bulk whole of the liquid into vapor state sida akoina vaporization haibasiga mari leinaba tam ni ko si boiling haisna. Evaporation is a surface phenomena masina akoigi liquid state amasung gaseous state animaki state amana amadai change tawba matumda thokpa phenomena ni kaiba evaporation. Particles from the surface gain enough energy to overcome the force of attraction present in the liquid and change into vapor state. Ngasagi liquid state ta leiramba pot ama gas state ta ongibudu okona evaporation with sida gaining enough energy to overcome the force of attraction present in the liquid. Liquid to the lemba force to magi liquid ta fazalaga amaga lemba particle ga amaga lemba force to the mana nanto kana vapor on bang ngambai gi adugi phenomena adubu evaporation. Fusion natraga melting sidana the process by which a solid change into a liquid. Solid leiramba mapang mai leiramba posa amadagi mahi oina olakpaduna akoina fusion. Sida solidification or freezing haina sina liquid tagi solid ta olakpa karam kanda by cooling indhara kanda ngasagi liquid ta leirambe posak sina solid ta olakpado. Example oina akoina ice IVI or any substance ama mahi langthor matungda amu mapang olakpado. Vaporization sina ngasagi sigi evaporation and boiling animakse akoina sida include tawrani the process by which a liquid change into a gaseous state ko. Liquid state ta leiramba posa amadagi gas ki state ta ongibaduna vaporization. Condensation the process by which a gas change into a liquid. Gas na liquid ta change tawrappaduna condensation. Aduga sida latent heat ana tamam lay latent heat is the amount of heat energy absorbed or released by a substance during a change of state without any change in the temperature. Posa mana ngasagi state liquid ta leiramba natra solid ta leiramba pot state matter mana magin atopa matter mada change tawba matamda state mada change tawba matamda hariba energy absorb amount of heat energy absorbed or release the latent heat haveneba. In simple term, the heat goes to into changing the state, not the temperature go. Masagi magi temperature di change to the bida state tang. Haibadi solid tagi liquid olapa liquid tagi gas on or gas tagi solid on bas mind to. Bagi magi amount of heat in absorb or release to bagi heat energy absorb or release to budu ko na latent heat kawe. Latent heat of evaporation hadi evaporation to bumutam da sang ba magi heat energy ki chang aduna latent heat of evaporation. Latent heat of fusion hai ta kana akoina solid state tagi liquid state ta on ba sang ba energy du bu akoina latent heat of fusion. Next the classification of matter. When matter ngasai solid magi matter do anything that occupies space and have mass to bu when matter hai kangnai hai matter jing do when classify into two broad classification lay magi mixture hai bam ne pure substance hai bam ne mixture da kai yaw hai ta contains particles of two or more pure substance which may be present in any ratio ko mixture hai ta ga magi pure substance or sida posak ani yanjanaba with any ratio da yanjanaba du mixture ka hoigo pure substance hai na forming mixture are called its component sida hai pure substance hai ta ga di magi component du particle magi sagalaiba component du gi particle मैम जे same particles na sagala oidoba and mixture की मागी characteristics है homogeneous or heterogeneous होबे हाबदी मागी ngasai sida in any ratio होबे number mo kana magi particles yauri bujing do when homogeneous or heterogeneous होबे hai in a homogeneous mixture the components completely mix with each other. Sugar solution and air are the examples of homogeneous mixture. Homogeneous mixture है मागी uniform composition लेबा मागी particles में आमदो अपन बोइना तोआन बा पुंजल तागा जो मागी uniform होइना पुंजल लकान लेबा दुगा heterogeneous है non uniform composition होइबा हाबदि अनि दु यानजनबा मतम दा अखोइना distinction लेबा any particle amga ani दुगी distinction लेता अगरि मदुन heterogeneous mixture कौदोनि so that the composition is not uniform throughout and sometimes different components are visible. For example, mixture of salt and sugar, grains and pulses along with some dirt. Sijina akoi heterogeneous example. Duga akoina sigi mixture ji akoina khandok nabagi techniques ai tare sida hand picking or sieving, manually picking large items or using a sieve to separate solids of different size. Example when akoina grains vibrate tawkanda akoina cheng khapa gumbadaga yam sinaba adudagidi maje shaking tawkanda sieving or hand picking akoina hand picking adi particles me andu sauraga akoina khunna gum lauthokpadun hand picking kawre sieving hai tare akoina madu nick kind of different size to akoina khandokpa ngambadu akoina sieving. Sedimentation and decantation. Sedimentation hai letting denser solid settle at the bottom sina sedimentation and carefully pouring out of the liquid sina decantation. Filtration hai passing a mixture through a filter paper to separate the insoluble solids and soluble solids from liquids or gases ko. Evaporation and crystallization. Heating a solution to vaporize the liquid area duga crystallization leaving behind dissolved solid crystals. Si akoina ising da yawba thum natragana ising yaw chini jing kamaina separate tawgre hai tagadi sigi technique sinar kanda hoina tongan tongan ba component ani do khandok pai distillation hai kana heating a liquid mixture to vaporize the component with the lower boiling point, then cooling it back to liquid with fractional distillation, separating liquids with closer boiling points. Sina akoina tonganba mixture mahi ngakta oiba jingdo akoina tonganba posak singdogi magi temperature boiling point tonganba leba amai tawdana boiling point low boiling point leba jingduna magi separate jaga amda jakrani aduga high oibaduna mu separate jaga amda jakrani amai tawdana tonganba component do liquid component do khuna sigi method se distillation haiba method se sinar kanda technique se sinar kanda khuna separate tawwe ai centrifugation haragadi spinning a mixture rapidly to force denser components to the bottom centrifugation haragadi khuna mayai da unga kanda mayai da phamjalakpa like in the blood test of or any atopa akhona component ma kha dong kan simana centrifugation haiba process sinar kanda separate tawwe ai magnetic separation using a magnet to extract magnetic materials like iron filings from non-magnetic ones. Sina separation of materials from non-magnetic ones. Habadi akona separate tawba matamda magnet na chingsanba pot ka chingsanba pot ani dum mixture oina leiba matamda akona separation tawga ha ta ga sigi magnetic separation je darkar le. Chromatography or paper the separating substance based on their different movement through a stationary medium like paper with a moving solvent. Sina akhoi medium like paper na kha kanda magi je kamaina tonga magi substance solvent adu tumma yawi jing do tonga mai paper gu mamana khaido kanda separate to du khona chromatography. Sublimation hai kan ngasai suya press separating a solid that change directly into gas from other solids. And pure substance hai ngasai some constituent particle do have a pure fixed composition like tare aduga when elements or any sida compounds वगैरह sida like copper silver gold हाइब्रिड से pure substance की मखा manung da changani when a pure substance is classified into two categories like elements and compounds. See elements and compounds when a pure substance is classified to be the elements when a element element an element is a pure substance made up of only one kind of atom and cannot be broken down into simpler substances by chemical means. Element a pure substance within yam sidagi magi leiba form sidagi hen kaithaba yadraba potubu akoina element and the element there are 118 officially recognized chemical elements identified by the IUPAC. Abda koina periodic table there yaw element je kaya hujibogi wena non element je 118 lay aduga masi manungda it consists of 94 naturally occurring elements. Nature da fangba mahusagi adum phanga leirabasina 94 aduga 22 sina synthetic man-made elements hybrid laboratory to saba element makhal neba sigi 24 sina out of 118. Compound is a pure substance form when two or more elements chemically combine in a fixed ratio and can be broken down into simpler substance only by chemical methods. Sigi compound hai bazna asagi pure substance do pumjan one or two ꯄꯨꯟꯁꯤꯟꯕ ꯌꯥꯏꯑꯕ ꯍꯦꯟꯅ ꯋꯥꯟ ꯑꯃꯗꯒꯤ ꯅꯠꯇ꯭ꯔꯒꯅ ꯑꯃꯗꯒꯤ ꯍꯦꯟꯅ ꯄꯨꯟꯁꯤꯜꯂꯀꯥꯟꯗ ꯁꯦꯝꯕ ꯏꯟ ꯐꯤꯛꯁ ꯔꯦꯁꯤꯌꯣ ꯑꯣꯏꯕꯗꯨꯕꯨ ꯑꯩꯈꯣꯏꯅ ꯀꯝꯄꯥꯎꯟꯁ and some sigar mari lenaba terms haitagati sida solution adi a solution is a homogeneous mixture in which a solute is completely dissolved in a solvent solute haigana ngasagi tungadoriba pot mixture ani duda ama tungadori pot duna solute and solvent haigadi mabu tumangadoriba posak tuna solvent aduga solution haitagadi homogeneous mixture way haiba anigi solute amasung solvent the particles are very small and do not settle on standing sida sol dissolve in water completely dissolve taurakanda laigiba potunbu solution suspension haigana a suspension is a heterogeneous mixture in which two solid particles are dispersed in a liquid but are larger enough to settle when left undisturbed. Suspension hain heterogeneous mixture makal amani sida akoina ngasagi liquid tu da tumiba posak chingje solid particles jingdo yam hena maji lengna thama matamna maningda phamjallakanda uba adumba makalgi mixture du akoina sigi suspension. Next, colloidal solution. A colloidal solution is a heterogeneous mixture in which very small particles of one substance are dispersed in another and do not settle on standing. Kasagi lengdana thamba matamda amadu suspension dudi madi phamdara kaneba maningda adubu sigi type of colloidal solution hai ta madi phamdada bida pulap particles single dippers in another and do not settle on standing lengdan thamba matamda mai di phamdaroi adubu ngasagi particle ahumdu yengba matamda sida magi common example gai di colloid ki common example gai di milk fork the smoke lairiba jelly or paint and whipped cream smaina magi colloidal solution gi example jingni aduga magi ngasagi solution ne colloid ne suspension ne haiba ahumji sida akoina picture jina represent tawbe yaba solution dutadi magi like mix tawriba ani do completely dissolve taw yawrani aduna magi akoi mitna yengba matamda maje akoina uba ngamoiba particle size na less than 1 nanometer aduga sigi colloid kina particle size 1 nanometer to 1000 nanometer aduga suspension da leiba si khaga tawraga maku khaga tawna tawraga yawra leibisina magi particle size greater than 1000 nanometer oiganeba sida makada piri table sida tongan ba colloid ki makhal leire ngasagi tumiba yanjanariba ni do disperse phase and dispersing medium sina gas the liquid yaw san baje akoina type sina aerosol khoi ising nushita yawba aphataba jing liquid substance sing haitaris the fog magi example of fog clouds mist laire adudagi solid ka gas ka punjalaga ju smoke automobile exhaust gas ka liquid ka punjalaga na foam semi shaving cream liquid ka na emulsion milk face cream haibajingse akoina example of colloidal solution eba simakada ju solid liquid punjalaga salt semi milk or magnesia and mud gas ka solid ka punjalaga na foam semi sida foam rubber sponge pimic liquid ka solid ka punjalaga na gel jelly gumba cheese gumba butter gumba haibajingina solid ka punjanba solid ka punjalagadi akoina solid solution colored gemstone natra milky glass haibajingse types of examples of colloid oidone siga colloidal solution siga mari leinaba ngasagi sida akoina solid ka gas ka tawon don sta aerosol baina form tawbse sigi phenomena je apana sida sigi tidal effect habjina akoina utba yagne the tidal effect is a phenomena by which a beam of light becomes visible when it passes through a colloidal solution or a fine suspension sigi phenomena je which mangal na faur lakpa matamda akhoi nusisida yauriba tongan tonganba magi particles dust particle oigera ana adadi ising marik oigera u nusisina mangalsina faur lakpa matamda uba ngambado adugi sida makhada yauriba picture sida uribase sigi form of sibo koina tidal effect na thon bani hai when a light passes through such a medium these particles scatter the light in different directions this scattering makes the part visible like sunlight streaming through a mist forest ko adubu si true solution oita agadi does not show the tidal effect because their particles are too small to scatter light ngasai sida colloid natragana suspension sigi type sida leibada akoina particle jingje true solution oita agadi tidal effect foi haba next up atoms and molecules atoms hai taragadi akoina an atom is the smallest particle of an element that can retains its element chemical property kasai element pure substance the element je ma sigi element sigi component mo oina akoina atom is the smallest particle of an atom atom sida mu kai yaw hai tari consists of several fundamental particles such as electron proton and neutron electron is negatively charged mana negative charge but proton has positive charge and number of electron and proton is in an atom is equal addition masagi sida leiriba charge ani je amana positive charge amana negative charge purta targasu animaksina equal and opposite charge oiba number makanda electrically neutral oil protons remain in the nucleus in the center of the atom and nucleus is surrounded by negative charge electron atom ama habse akoigi proton lerani aduga electron gaina magi akoibada ungaga leyaba adisida total number of protons and electrons is called akon atomic mass hai taragadi number of total number of proton and electron du akona atomic atom mass number hai taragadi total number of protons and neutrons du mass number ado discovery of electron kanana discover tawge hai J Thomson general knowledge when hangpa ya question da aduga proton kanana tawgidi Ernest Rutherford na ko aduga neutron na James Chadwick na atoms and molecules siga mari lenaba koina term jing sida sinari se isotopes hai taragadi are variant of particular element in which different number of neutrons kasagi neutron di magi discharge laite adubu neutron na magi atomic mass che oidoine n keno magi atom amagi weight mass e kaina oi hai tari the total number of proton and neutron oeba neutron da kai different number of neutron lay putari same element amagi tongan ba neutron lay ko tagri madu ko na isotopes kawe for example the two isotopes of uranium 395 agar 235 and uranium 239 ko ani jigi neutron khena number mo kana maje variants of element oira ka doine ba adsibu akoina isotopes side Targana are elements that have the same number of nucleons, same sum of the proton and neutron ko. Adubu, the series of elements with 40 mass numbers serve as a good example. Sida piriba tongan tongan bi elements sida calcium natragana argon leiba jingje kedaba magi tongan tongan ba mass number leiragadi akoina isobar aduga
Voice taakidre. Sir, voice taakidre.
letar bauze
Ah,
hello tarbo
tar.
oh ai network mangu male dugi screen share tawdu ui ko
Wait.
oh okay and isotons haitagadi are the atoms that have the same neutron masing chamanaba aduga proton da khenabaduna akoina isotons kaweba example oina sida leba sulfur adadi potassium argon leba jingja are the isotons of 20 since they all contain 20 neutrons masing chamanaba mogi atom jingdubu akoina isotons aduga sida molecule haitagadi is an aggregate or two or more than aggregate of two or more than two atom ani natra ani di hena punjanba with of the same element or different element in definite arrangement tongan tongan ba element ani punjanaba natra manaba element ani definite arrangement tawrakan punjandubu akoina molecule akoina water gi molecule kai haib adudubu akoina sigi molecule hai tari admaina same different types of elements natra atoms punjanbadubu akoina molecule. Then an atom is the smallest particle of a substance but can not exist freely. Atom haibdudi ngasai tongan maji freely oina leiba ngamdeba but molecules hai ta ngasai tongan ba atom jing natragana element jing pujalakanda maje can exist alone or freely under ordinary conditions ko. Molecular mass hai tari it is the sum of atomic masses of all the atoms present in the molecule. Ngasai molecule any atom natragana element pujalagan semiba dugi magi sum of the atomic masses to bokoina molecular mass haraga khangnei isomer sigi tamsina are molecules or polyatomic ions with an identical molecular formula. It is the same number of atoms of each element but distinct arrangement of atoms in space. Isomers ꯍꯥꯏꯔꯒꯅ ꯁꯤꯅ ꯆꯞ ꯃꯥꯟꯅꯕ ꯃꯥꯒꯤ ꯁꯦꯝ ꯐꯣꯔꯃꯨꯂꯥ ꯂꯩꯕ ꯑꯗꯨꯕꯨ ꯃꯥꯒꯤ ꯏꯂꯤꯃꯦꯟ ꯌꯥꯎꯔꯤꯕ ꯏꯂꯤꯃꯦꯟ ꯑꯣꯔ ꯅꯠꯇ꯭ꯔꯒ ꯑꯦꯇꯣꯝꯁꯤꯡꯗꯨꯒꯤ ꯃꯥꯒꯤ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ ꯗꯤꯁꯇꯤꯡꯁꯟ ꯂꯩꯔꯒ ꯃꯥꯅ ꯑꯦꯔꯦꯟꯖꯃꯦꯟ ꯇꯧꯕꯗꯣ ꯑꯗꯨꯒꯤ ꯃꯈꯜꯒꯤ moleculesꯇꯨꯕꯨ ꯑꯩꯈꯣꯏꯅ isomers ꯍꯥꯏꯔ ꯈꯪꯅꯩ. Next, periodic table of the elements. Periodic table ꯑꯩꯈꯣꯏꯅ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ ꯃꯈꯜꯒꯤ periodic table ꯃꯣꯏꯒꯤ ꯁꯥꯏꯟꯇꯤꯁꯁꯤꯡꯅ ꯄꯨꯊꯣꯛꯑꯝꯕ ꯂꯩ ꯑꯗꯨꯕꯨ ꯑꯩꯈꯣꯏꯅ ꯁꯤꯗ ꯉꯁꯤꯒꯤ ꯇꯣꯄꯤꯛꯁꯤꯗ ꯃꯦꯟ ꯐꯣꯀꯁ ꯑꯣꯏꯅ ꯇꯧꯗꯣꯏꯁꯤꯗꯤ periodic table ꯑꯩꯈꯣꯏ modern periodic table ꯍꯥꯏꯔꯒꯁꯨ ꯈꯪꯅꯕ ꯖꯦ ꯑꯣꯏꯅ ꯅꯩꯅꯒꯅꯤ. ꯁꯤꯗ ꯑꯩꯈꯣꯏꯅ modern periodic tableꯗ ꯀꯃꯥꯏꯅ ꯍꯥꯏꯕ ꯌꯥꯏ ꯀꯥꯟꯗ the physical and chemical properties of the elements are periodic functions of their atomic numbers. ꯍꯥꯏꯔꯤꯕꯁꯤꯒꯤ modern periodic tableꯁꯦ ꯑꯩꯈꯣꯏꯅ ꯃꯥꯒꯤ atomic ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ element ꯂꯩꯔꯤꯕꯁꯤꯡꯁꯤꯒꯤ atomic numberꯒꯤ ꯃꯇꯨꯡ ꯏꯟꯅ ꯑꯩꯈꯣꯏꯅ ꯁꯤꯗ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ group or periods ꯍꯥꯏꯅ ꯈꯥꯏꯗꯣꯛꯔꯛꯀꯅꯦꯕ. ꯁꯤꯗ ꯑꯩꯈꯣꯏꯅ a period ꯁꯤꯗ ꯑꯩꯈꯣꯏꯅ periodic tableꯁꯤꯗ ꯌꯦꯡꯕ ꯃꯇꯝꯗ period 7 periods ꯂꯩꯅꯤ. horizontal rowꯗ ꯁꯨꯃꯥꯏꯅ ꯂꯩꯔꯤꯕꯁꯤꯅ red line sida the red line shows the different periods aduga green line sina 1 to 18 leribasina groups oigane adu moi jingje moi similar chemical properties leiba ngaktane ba khona sida how it is arranged hai mana period ta thamaiba period or group ta thamaiba element jing se tongan tongan ba magi chemical properties leijaraga similar oiba properties leiba jing je akoina group नत्रगा पेरेंट्स इन खाइदो थमकनी अखाता सिदा अखोइना ग्रुप ता खाइदो थमकबा मेटेरियल सिदा अखोइना अल्काली मेटेरियल्स ग्रुप नंबर 1 इसिगी हाइड्रोजन हेलियम लिथियम हाइड्रोजन लिथियम सोडियम पोटेशियम सिगी लेरिबा ग्रुप नंबर 1 जी यावरिबा एलिमेंट जिंग जिबो अखोइना alkali metals kawigo sida akoina exception of with the exception of hydrogen this metal consists moje alkali metals kawi. These elements are extremely reactive and for this reason moje they are usually found in compounds for the mojing je tongana leibana taba compounds oina ngasai compounds hai more than one or two elements punjala kan sembado akoina compound hai man tawdana moje nature da se art sida akoina moje compounds in phangi aduga they are water sensitive and they must be stored in oil ko moje sensitive yam leiba and they react violently with water oibna maram kana moje oil ga ju thame the most reactive alkali metal is francium and it decreases as you go up the group ko asagi reactivity of the alkali metal je akoina mathalom da kakhalakpa matamda sum magi keno je handarakane reactive element ring handarakane ba this means lithium is the least reactive oiba element physically the alkali metal family is silvery mogi physical property the silvery white and light they also have low melting and boiling points ko so I talk dana alkaline art metal hai group 2 da leiba jingje akoina alkaline art metal hai khangnei it can sida ngasagi sigi kangu jine it is the second most reactive family of the periodic table ko mogi properties they are also good thermal and electrical conductors physically they have low density low melting point and boiling point ꯃꯈꯥ ꯇꯥꯔꯛꯄꯗ ꯔꯤꯌꯔ ꯑꯥꯔꯠ ꯃꯦꯇꯦꯜꯁ ꯑꯣꯔ ꯂꯦꯟꯊꯅꯥꯏꯠ ꯍꯥꯏꯇꯥꯔꯒꯗꯤ ꯉꯁꯥꯏꯒꯤ ꯑꯩꯈꯣꯏꯅ ꯄꯦꯔꯣꯗꯤꯛ ꯇꯦꯕꯜꯗ ꯃꯈꯥꯒꯤ ꯁꯤꯒꯤ 6 and 7 ꯁꯤꯗ ꯂꯩꯔꯤꯕꯁꯦ ꯁꯤꯒꯤ ꯇꯣꯉꯥꯟꯕ ꯃꯣꯏꯁꯤꯡꯁꯦ ꯑꯩꯈꯣꯏꯅ ꯁꯤꯒꯤ ꯄꯦꯔꯣꯗꯤꯛ ꯇꯦꯕꯜꯁꯤꯗꯒꯤ ꯇꯣꯉꯥꯟ ꯊꯝꯃꯤꯁꯦ ꯃꯣꯏꯁꯤꯡꯁꯦ ꯁꯤꯗ ꯍꯥꯞꯄꯗ ꯃꯥꯒꯤ ꯄ꯭ꯔꯣꯄꯔꯇꯤꯁꯤꯡꯁꯦ ꯃꯥꯟꯅꯔꯒ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ ꯃꯥꯒꯤ ꯀꯦꯃꯤꯀꯦꯜ ꯄ꯭ꯔꯣꯄꯔꯇꯤꯁꯤꯡꯁꯦ ꯃꯥꯟꯅꯕꯁꯤꯡꯁꯦ ꯇꯣꯉꯥꯟꯅ ꯁꯣꯝ ꯅꯥꯀꯟꯗ ꯄꯨꯊꯣꯛꯑ ꯊꯝꯃꯤ ꯁꯤꯒꯤ ꯁꯤꯡꯁꯤꯕꯨ ꯑꯩꯈꯣꯏꯅ lanthanide कवे सिगी lanthanide are a family of rare earth metals moi rare earth metals कवे rare earth metals हाय तारगदि अखोइना यामना आर्ट सिदा फंगबा तोंगान तोंगान मेटल मरकता मोइजे तोंगान सिनाबम अखोइ रेडियो एक्टिव ओइबा जिंजिबो अखोइ rare earth metal कवेबा सिजिंजे अखोइना सिगी lanthanide series दे यावे they are highly reactive and strong reducing agent in reaction को मागी तोंगानबा सिदा मागी silvery and bright metal and relatively soft मागी physical characteristics later and they also have both high melting point and high boiling point. Next sida rare earth metal actinides ko actinides later actinides are another family of rare earth metals season tawi aduga these metals are highly moisu chamanana ngasai reactive yamna wangba elements and they also have high electropositivity and are radioactive. Additionally, these elements contain paramagnetic, pyromorphic, and allotropic properties. Physically, they are very similar to lanthanides. Adubu magi chemical ditati moina highly reactive oibe heli and they also have high electropositivity and radioactive oibe heli ngasagi lanthanides tagi. Transition element haigana group ethyl lebung the 3 to 11 do akhona transition element gawi siga the transition metals typically form two or more oxidation states they have low ionization energy and high conductivity go in addition they have high melting point high boiling point and high conductivity physically they are both metallic and malleable see the level 3 to 11 the level group sing metallic character loina seli aduga post transition metal hai taragadi the post transition metal are located in between the transition metal and the metalloids sina at center level they are in a solid state of matter they tend to have a high density as well as high conductivity physically they are malleable and ductile and metalloids hai taragadi the metalloid display properties of both metal and non-metals ko sigi element modern periodic table sida magi sida leiriba jingjibo koina metalloids hai khane ba sigi leiriba jingje moigi properties je kamai to ya kanda metalloid display property of both metal and non-metal animal character to chen ba and for example metals are good conductor or sai metal na good conductor oi aduga non metal na poor conductor oi this means metalloid are semiconductor metalloid sing semiconductor oi aduga and also they are more brittle than metals but less brittle than non-metals physically they can be either shiny or dull and are typically ductile and malleable. Group 17 group 17 là khối halogens hai khang nei sida the name halogen means salt forming in Greek word tamari salt forming hai bane halogen this is an evident in nature as halogen interacts with metal to form various salts ko si non metal jingjigna mage ahoi ki metal ga react taw matam da salt seme sumaina akoina there are 6 halogens and they are located in group 17 the level akoina halogen ko hai gre aduga halogen kya le hai ta 6 le these elements include fluorine chlorine bromine iodine and statin ko. They are highly reactive, highly electronegative, and highly toxic nonmetals ko. Noble metals hairgana consist of ruthenium, osmium, rhodium, iridium, platinum, gold, silver. Sina noble gas ka mana na moina they are inert due to having a complete balance hybrid modi reactivity je reaction am thok tabi element jing ne si noble materials hairgana siga zamana na somna kana noble gas group 18 da labor noble gasing je akhona je moi je erogens kawi or inert gas haga khangne some examples are argon krypton neon high bridging is a reaction token jaba element jing never they are found in group 18 on the periodic table like why this means they are complete balance cell ko moi electron electronic configuration the magi outermost shell to the complete balance cell leibna maram kanda stable oi bhai tar they are stable and relatively unreactive oi ko and furthermore the noble gas have low boiling points and low melting points ko physically they are colorless and have no smell hai bai element jing se mogi boiling point low oiba melting point low oiba aduga physically they are colorless and have no smell okay sisina samana sina classification based on electromagnetic configuration da ko ngasai samana ba akhoi modern periodic table do akhoi classification je mana ngasai na period group oina classify tawba sina block s block element or p block and sida d block and f block element haiga tongan ba magi tongan na classification tawbane based on the electronic configuration ko next metal non-metal and metalloids akhoi element jingje akhoi ngasai physical and chemical properties yang akanda akhoi moi jingje classify tawbada akhoi metals haigana lustrous malleable and are good conductor of heat and electricity of the akhoi metal kawi non-metal haigana non-metal are elements that do not share the properties ngasai sida lustrous oiba langba adudagi di mahi oina langthon be aba natragana electricity conduct tawba ngamba heat amasung electricity conduct taw ngamba je akhoi metal haibdo adu opposite non metal jina magi properties je cheli metalloids haigana there see the mixture of properties of metals and non-metals in a metalloid alloy haigana a mixture which two or more different elements are blend together at least one of them are always metal ngasagi metal amaga any non-metal amaga natra metallo amga punjalakanda akhoi mixture sem badubu alloy kaweba sida tongan akhoi alloy makhal mayam lere sida brass bronze solder stainless steel german silver gunmetal dura lumin and magnesium haiba jingse mogi tongan sida uses lai ko decorative articles tapes extra sida si jingje akhoi kai punjala sene copper net jing ne punjala kan semeba sing sumaina different types of alloys ni ko se and from the allotropes hai ta gadi allotropes are different structural form of the same element in the same physical state solid liquid or gas exhibiting distinct physical and chemical properties due to variation and atomic arrangement allotropes hai gadi ngasai same element amagi magi tonganba physical and chemical properties leirako element amagi leiriba magi chemical magi structure je kengma change tawthokuma madumna magi tonganba form do oina lakpado tonganba distinctive magi physical and chemical properties oina tholeeba ngasai atomic arrangement je tawuma madumna singba types of ꯏꯂꯤꯃꯦꯟꯗꯨꯕꯨ ꯑꯩꯈꯣꯏꯅ ꯑꯦꯂꯣꯇ꯭ꯔꯣꯞꯁ ꯍꯥꯏ ꯈꯪꯅꯩꯑꯕ ꯑꯦꯛꯖꯥꯝꯄꯜ ꯑꯣꯏꯅ ꯁꯤꯗ ꯀꯥꯔꯕꯣꯟ ꯍꯥꯏꯕ ꯏꯂꯤꯃꯦꯟꯁꯤꯒꯤ ꯃꯥꯒꯤ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ ꯑꯦꯇꯣꯃꯤꯛ ꯑꯦꯔꯦꯟꯖꯃꯦꯟ ꯇꯧꯕ ꯃꯇꯝꯗ ꯑꯩꯈꯣꯏꯅ ꯗꯥꯏꯃꯟ ꯒ꯭ꯔꯦꯅꯥꯏꯠ ꯍꯥꯏꯕꯁꯤꯡꯁꯦ ꯑꯩꯈꯣꯏꯅ ꯁꯦꯝꯕ ꯌꯥꯏ ꯗꯥꯏꯃꯟꯒꯤ ꯃꯥꯒꯤ ꯐꯤꯖꯤꯀꯦꯜ ꯄ꯭ꯔꯣꯄꯔꯇꯤꯁ ꯑꯦꯟ ꯀꯦꯃꯤꯀꯦꯜ ꯄ꯭ꯔꯣꯄꯔꯇꯤꯁꯦ ꯄꯨꯔꯥ ꯆꯦꯟꯖ ꯇꯧꯗꯣꯏꯅꯦꯕ ꯍꯥꯔꯠ ꯑꯦꯟ ꯏꯟꯁꯨꯂꯦꯇꯤꯡ ꯑꯣꯏꯕ ꯑꯗꯨꯒ ꯒ꯭ꯔꯦꯅꯥꯏꯠꯁꯤꯗꯅ ꯁꯣꯐ ꯑꯦꯟ ꯀꯟꯗꯛꯇꯤꯚꯤꯇꯤ ꯑꯣꯏꯕ ꯁꯨꯃꯥꯏꯅ ꯃꯥꯒꯤ ꯆꯞ ꯃꯥꯟꯅꯕ ꯏꯂꯤꯃꯦꯟ ꯑꯃꯒꯤ ꯄ꯭ꯔꯣꯄꯔꯇꯤ ꯑꯣꯏꯔꯒꯁꯨ ꯑꯦꯔꯦꯟꯖꯃꯦꯟ ꯃꯥꯒꯤ ꯑꯦꯇꯣꯃꯤक ꯑꯦꯔꯦꯟꯖꯃꯦꯟꯗꯣ ꯆꯦꯟꯖ ꯇꯧꯕ ꯃꯇꯝꯗ ꯄꯣꯠꯁꯛꯇꯨꯒꯤ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯕ ꯄ꯭ꯔꯣꯄꯔꯇꯤ ꯇꯣꯉꯥꯟ ꯇꯣꯉꯥꯟꯅ ꯆꯦꯜꯂꯛꯑꯦꯕ ꯑꯦꯂꯦꯛꯇ꯭ꯔꯣꯞꯁ ꯍꯥꯏꯔꯒꯗꯤ corrosion is a natural and gradual degradation of materials primarily metals through chemical or electrochemical reaction with their environment converting refined metals into more stable oxide natra hydroxide or sulfide corrosion hai taagadi degradation of masai ꯂꯩꯔꯝꯃꯤꯕꯗꯨꯗꯒꯤ ꯑꯦꯅꯤ ꯑꯦꯛꯁꯇꯔꯅꯦꯜ ꯏꯟꯚꯥꯏꯔꯣꯟꯃꯦꯟꯗ ꯂꯩꯔꯤꯕ ꯐꯦꯛꯇꯔꯁꯤꯒ ꯃꯥꯒ ꯔꯤꯌꯦꯛꯁꯟ ꯊꯣꯛꯑꯀꯥꯟꯗ ꯀꯦꯃꯤꯀꯦꯜ ꯔꯤꯌꯦꯛꯁꯟ ꯊꯣꯛꯑꯀꯥꯟꯗ ꯀꯟꯚꯔꯇꯤꯡ ꯉꯁꯥꯏꯒꯤ ꯃꯦꯇꯦꯜꯗꯣ ꯀꯩꯗꯧꯕ ꯃꯥꯒꯤ ꯑꯣꯛꯁꯥꯏड ꯅꯠꯇ꯭ꯔꯒ ꯍꯥꯏꯗ꯭ꯔꯣꯛꯁꯥꯏड ꯑꯣꯔ ꯁꯜꯐꯥꯏꯗꯇ ꯑꯩꯈꯣꯏꯅ ꯗꯤꯒ꯭ꯔꯦꯗ ꯀꯥꯏꯊꯔꯛꯄꯗꯨꯕꯨ corrosion ꯍꯥꯏꯔ ꯈꯪꯅꯩ ꯃꯥꯒꯤ ꯑꯦꯛꯖꯥꯝꯄꯜꯗ रस्टिंग ऑफ आयरन को आयरन अखोना कॉलिंग कारक पाइबदो मागी केमिकल फॉर्म ऑक्साइड ता फॉर्म तौरपगी Fe2O3 and H2O सिदा X हाइजना amount of water दो दिने सिदा moisture or moisture from the air with combines with the oxygen to form rust. Rust is a form of hydrated ions of iron iron oxide. This is rusting. And tarnish patima is a surface oxidation reaction that occurs on metal like copper, silver, and brass when they are exposed to air, moisture, and pollutants. Sina karamba element metals copper gumba silver gumba brass gumba sina akhoi mapanda thamba matamda magi to property to change tawrapado reaction thokanda the reaction forms a thin layer of compounds on the metal surface in architecture and art but patina is often desired for aesthetic value adulagi in daily use tannin may be removed to restore shine ko akoina makshallakpado onung reaction thokanda akoina makshallakpa jingdo akoina si tarnish or patima hai khangneiba aluminum oxide aluminum oxide is a thin hard and protective oxide layer that forms naturally when aluminum is exposed to air akon aluminum coil natraga any aluminum coil mapanda tawu matamda ngasai environment gi reaction thokanda mana magi surrounding magi head surrounding the layer am form tawkodo surface to da अदुबो खोना सिगी एल्युमिनियम ऑक्साइड है खंगनेबो मोइजना कमाइन तौगे है काना ngसागी पोतो मखा ताना रिएक्शन थोक्तनाबा मोइ मसा मथोंदा थोल ऑक्साइड ओना फॉर्म तौर कान लेयर म सेम लेगिदोनेबा मसिना मरम कान मंगोंदा मखा ताना सोकपगी चांगदो हंदरकने and galvanization it is a process of applying a protective zinc coating to iron or steel to prevent rusting and corrosion ngasai iron gumba steel gumba da corrosion or rusting cooling ka ba jing thok pado adu phana gi nam ta khoina mongon da layer ma tisan bado less reactive oiba element have the iron da gi di si zinc sina less reactive oibani na sigi coating ma tisan la kanda khoina posak tu kuina thamba yana ba kuina chanabagidamagta akhona sigi process galvanization haiba process se akhona iron metals or steel da toksanganeba the most common method is hot dip galvanization which involves dipping component into molten zinc. ꯃꯍꯤ ꯑꯣꯏꯅ ꯂꯩꯔꯤꯕ ꯖꯤꯡꯛꯇꯨꯗ ꯑꯩꯈꯣꯏꯅ ꯂꯨꯞꯄ ꯀꯥꯟꯗ ꯃꯥꯒꯤ ꯂꯦꯌꯔ ꯑꯃ ꯒꯜꯚꯅꯥꯏꯁ ꯇꯧꯍꯟꯕꯗꯨꯕꯨ ꯑꯩꯈꯣꯏꯅ ꯁꯤꯒꯤ ꯃꯦꯊꯗ ꯒꯜꯚꯅꯥꯏꯖꯦꯁꯟ ꯍꯥꯏꯕ ꯄ꯭ꯔꯣꯁꯦꯁꯁꯤꯗ ꯇꯧꯒꯅꯤ ꯑꯗꯨꯒ ꯁꯤꯗ ꯑꯣꯔ ꯍꯥꯏꯔꯒꯗꯤ an ore is a natural rock or sediment containing valuable minerals, usually metals, in concentration high enough to be economically mined and processed for profit, like iron ore or copper ore ko. Ore hagdi natural da fangba containing valuable minerals yaubse akhona ore hai khangeba dhatu sorry ore sai ta agadi akhona natural da fangba mangondagi sungdoktriba posak tu akhona ore hai kawe to ore ja tongan tongan ba magi ngasai gi lei ore dagi akhona tongan tongan ba posak singda metal natragana magi composition akhona lokthokning ba jingdo magi process tongan tongan ba process tor kana lokthokpa yai ba adu sida list sida piriba table sida yawise ore makhal mayam pire aluminum metal dana aluminum gi da ore bauxite diaspore goldite ꯍꯥꯏꯔꯤꯕꯁꯤꯡꯁꯦ ꯃꯥꯏ ꯀꯝꯄꯣꯖꯤꯁꯟ ꯑꯦꯂꯨꯃꯤꯅꯝ ꯌꯥꯎꯕ ꯀꯝꯄꯣꯖꯤꯁꯟꯁꯦ ꯑꯩꯈꯣꯏꯅ ꯑꯦꯂꯨꯃꯤꯅꯝ ꯐꯪꯅꯕꯒꯤꯗꯃꯛꯇ ꯍꯥꯏꯔꯤꯕꯁꯤꯒꯤ ꯑꯣꯔꯁꯤꯡꯁꯤꯗꯒꯤ ꯑꯦꯛꯁꯇ꯭ꯔꯦꯛ ꯇꯧꯒꯅꯦꯕ ꯆꯞ ꯃꯥꯟꯅꯅ ꯁꯤꯗ ꯑꯥꯏꯔꯟꯒꯤꯁꯨ ꯆꯞ ꯃꯥꯟꯅꯅ ꯁꯤꯗꯒꯤ ꯑꯦꯛꯁꯇ꯭ꯔꯦꯛ ꯇꯧꯒꯗꯣꯏꯅꯦꯕ ꯃꯥꯒꯤ ꯄꯥꯔꯁꯦꯟꯇꯦꯖ ꯌꯥꯎꯔꯤꯕ ꯆꯥꯡꯗꯨꯒꯤ ꯃꯇꯨꯡ ꯏꯟꯅ ꯀꯣꯄꯔꯁꯨ ꯀꯣꯄꯔꯁꯤ ꯀꯣꯄꯔ ꯄꯥꯏꯔꯥꯏꯠ ꯀꯣꯄꯔ ꯒ꯭ꯂꯥꯟꯁ ꯀ꯭ꯌꯨꯄ꯭रिꯛ ꯅꯠꯇ꯭ꯔꯒ ꯃꯦꯂꯥꯁꯥꯏꯠ ꯅꯠꯇ꯭ꯔꯒ ꯑꯖꯨꯔꯥꯏꯠ ꯍꯥꯏꯔꯤꯕꯁꯤꯡꯁꯤꯗꯒꯤ ꯑꯩꯈꯣꯏꯅ ꯑꯦꯛꯁꯇ꯭ꯔꯦꯛ ꯇꯧꯒꯅꯦꯕ ꯃꯥꯒꯤ ꯑꯣꯔꯗꯨꯗꯒꯤ See. Okay. And acid, base, and salt cost. In a subtopic of acid, base, and salt. Acid like an acid is a substance which furnishes hydrogen ions when dissolved in water. Acid hai any substance which isingda thadaba matamda which when dissolved in water it gives out hydrogen ions. Hydrogen ion thadorkudu akoina acid hai khangnai. Example sida hydrochloric acid in gastric juice, carbonic acid in soft drinks ko, ascorbic acid vitamin C akoina common name da vitamin C hai khangnaba jing asi jing je akoina acid singi manung jangani base hai a base is a substance which furnish hydroxide ions when dissolved in water. Hydroxide ion thadorpa water ga dissolve to matamda hydroxide ion thador masigi substance dubo akoina base and haineba sida and the term alkali is often used for water soluble base. Water isingda tumba base makhal jibo alkali hai khangnai. Some example of base are sodium hydroxide or caustic soda. Akoina sodium hydroxide se akoina common name da caustic soda kawi used in the washing soap. Akoina washing soap when sinaribje chemical name da sodium hydroxide kawi and sida potassium hydroxide or potash used in bathing soap ko. Sumaina tawdan tuan tuan ba alkali base makhal mayam leire sida salt are ionic compounds made up of cation other than hydrogen ion and anion other than hydrogen ion ko sida hydrogen ion ga hydroxide ion ga nataba atopa ion jingjibo akoina salt hai khangnaiba. And some commonly used salt are baking soda. Chemically, baking soda is sodium hydrogen carbonate ko. Magi chemical name je. Aduga limestone is calcium carbonate ko. Aduga washing soda. Chemically, sodium washing soda is sodium carbonate decahydrate ko. Bleaching powder is a process of removing color from the clothes. Aduga magi chemical name jina calcium oxychloride ko and sida pH scale pH scale haitagadi is a commonly used scale to measure ngasai acidity and basicity of a substance amagi acidity chang or basicity chang do ona bidumak do akhona pH scale lei maje akhona sida ranging from 1 to 14 1 to 14 the maji range tawi aduga 7 haibisina 7 perfectly neutral substance will have a pH value of 7 ko 7 sigi 7 sida laigadobisina neutral oiba substance kai leini aduga right lom da chalagana alkaline hengalakadoba aduga left lom chalagana acidic ki chang hengalakadoba sigi matungina akhona sida tongan tongan ba common acids khar leire sida piri sigi matungina magi pH scale pH value haitare tongan tongan pH value leire sigi table sing je dum loina yengjanba yarni ko aduga loisalapada sigi chemical compounds akhona nungtigi sinaba natragana akhona akoibada leiba tongan tongan ba compounds chemical compounds mayamni aduga magi formula jing haitare ko sida aspirin baking soda bleaching powder chemical name dana calcium chloro chlorohypochlorite ko bleaching powder aduga magi chemical formula smain tawdana tongan tongan ba element compounds mayam pire amaju mai common name pire and chemical formula jing haitare sijingje adum chifa pusanba darkar lei ko heng karigumba exam da magi chemical common name or chemical compound du kaino na hang targadi sigi chart table sing jen ming jen be siga manaba dum ming jen be then sina hojiki duga samana bada dum wan uses sida tonga tonga ba uses chemical substance jing haitare ko magi I name chemical form chemical name leire IPC name or molecular formula leire IPC name leire aduga common name of the chemicals ko aduga magi uses tonga tonga ba sida uses piri akoina nungtigi sinabda basic baking soda sodium hydrogen carbonate natraga sodium bicarbonate haibisingje akoina use in baking release ISO2 during cooking and sigi soap akoin sapon je kai no ai ta ni madi sodium salts of fatty acids ko ester side dina magi IPC name or natragana chemical name ko see my uses na used for bathing and washing clothes like detergent sodium sulfide mai tau dana tongan tongan ba sida akoina nuti gi thengna ba tongan ba chemical substance ingi magin chemical formula amachung chemical name amachung magi tongan tongan ba sinabam jing haitare ko sijingje sida pire sijingje akoina adum khaga yengjanba mathau tai exam ma mari leina haitare loisalakpada jigi international system of unit akoina SI unit haibje sije akoina part of kano physics ru obi aduga si chemical chemistry ki saruk da yaw bi ba sina SI unit has 7 base units and there are sida 7 base unit later and 7 fundamental scientific quantities ko magi quantities physical quantity later sida symbol magi symbol later aduga unit magi lairiba quantity jigi unit SI unit standard unit ko international unit of system of unit ko SI unit se laire akhona sida muk siga mai na sida tem sida di am atopa mamangi question jing hangba matam na sida akhona weight kumba volume kumba or any sigi laising sida di conversion gi je pa laite aduga sigi temperature gi sida question khar lakre mamangda हाइरिबा सिगी टेम्परेचर जे अखोइना टेम्परेचर ओन बजे अखोइना डिग्री सेल्सियस फारेनहाइट एंड केल्विन हाइना लई अदुगा तसेंगबा मागी SI unit केल्विन नेबा ꯑꯩꯈꯣꯏꯅ ꯁꯤꯒꯤ ꯀꯃꯥꯏꯅ ꯂꯩꯔꯤꯕ ꯁꯤꯒꯤ ꯃꯦꯖꯔꯃꯦꯟ ꯑꯍꯨꯝꯁꯦ ꯗꯤꯒ꯭ꯔꯤ ꯁꯦꯜꯁꯤꯌꯁ ꯐꯦꯔꯦꯟꯍꯦꯠ ꯑꯦꯟ ꯀꯦꯜꯚꯤꯟ ꯑꯍꯨꯝꯁꯦ ꯀꯃꯥꯏꯅ ꯇꯧꯗꯅ ꯑꯃꯒ ꯃꯥꯒꯤ ꯇꯦꯝꯄꯔꯦꯆꯔꯁꯦ ꯀꯃꯥꯏꯅ ꯀꯟꯚꯔꯖꯟ ꯇꯧꯒꯅꯤ ꯍꯥꯏ ꯇꯥꯔꯒꯗꯤ ꯁꯤꯗ ꯂꯩꯔꯤꯕ ꯐꯣꯔꯃꯨꯂꯥꯁꯤꯡꯁꯦ ꯁꯤꯖꯤꯟꯅꯔꯀꯥꯟꯗ ꯇꯧꯕ ꯌꯥꯏ ꯐꯦꯔꯦꯟꯍꯦꯠ ꯀꯌꯥꯒ ꯁꯦꯜꯁꯤꯌꯁ ꯗꯤꯒ꯭ꯔꯤ ꯀꯌꯥꯒ ꯃꯥꯟꯅꯩ ꯍꯥꯏ ꯇꯥꯔꯒꯗꯤ ꯁꯤꯒꯤ ꯐꯦꯔꯦꯟꯍꯦꯠ equal to 9/5 degree celsius plus 32 ꯀꯣ ꯁꯤꯅ ꯑꯩꯈꯣꯏꯅ ꯆꯦꯟꯖ ꯑꯣꯐ ꯐꯦꯔꯦꯟꯍꯦꯠꯇ ꯗꯤꯒ꯭ꯔꯤ ꯁꯦꯜꯁꯤꯌꯁ ꯑꯃ ꯄꯤꯔꯝꯕꯗꯒꯤ ꯐꯦꯔꯦꯟꯍꯦꯠꯇ ꯑꯣꯟꯒꯦ ꯍꯥꯏ ꯇꯥꯔꯒꯗꯤ ꯁꯤꯒꯤ ꯐꯣꯔꯃꯨꯂꯥꯁꯤ ꯁꯤꯖꯤꯟꯅꯕ ꯌꯥꯏ ꯑꯗꯨꯒ ꯀꯦꯜꯚꯤꯟꯒ ꯁꯦꯜꯁꯤꯌꯁ ꯗꯤꯒ꯭ꯔꯤꯒ ꯀꯃꯥꯏꯅ ꯃꯔꯤ ꯂꯩꯅꯩ ꯍꯥꯏꯔꯒꯗꯤ ꯀꯦꯜꯚꯤꯟ ꯑꯃ ꯍꯥꯏꯕꯁꯤ ꯑꯩꯈꯣꯏꯅ ꯁꯦꯜꯁꯤꯌꯁ ꯗꯤꯒ꯭ꯔꯤ ꯄ꯭ꯂꯁ ꯄꯤꯔꯝꯃꯤꯕ ꯁꯦꯜꯁꯤꯌꯁ ꯗꯤꯒ꯭ꯔꯤ ꯄ꯭ꯂꯁ 273.15 ꯀꯣ ꯁꯤꯒꯤ ꯚꯦꯂꯨꯁꯤ ꯑꯦꯗ ꯇꯧꯁꯜꯂꯀꯥꯟꯗ ꯑꯩꯈꯣꯏꯅ ꯀꯦꯜꯚꯤꯟ ꯑꯃꯒ ꯁꯦꯜꯁꯤꯌꯁ ꯗꯤꯒ꯭ꯔꯤꯗꯨꯒ ꯃꯥꯟꯅꯩꯅ ꯍꯥꯏꯕ ꯌꯥꯏ ꯀꯩꯗ ꯂꯣꯏꯁꯤꯜꯂꯛꯄꯗ ꯑꯩꯈꯣꯏꯒꯤ ꯃꯃꯥꯡꯒꯤꯗ ꯍꯪꯕ ꯀꯣꯏꯁꯟꯁꯤꯡ ꯀꯣ sida which of the following are primarily responsible for acidic acid ꯑꯩꯈꯣꯏꯅ acidic acid or acid rain ꯀꯣ acid rain ꯍꯥꯏꯕꯁꯤꯗ primary responsible ꯃꯥꯒꯤ ꯁꯤꯒꯤ ꯁꯤꯗ ꯌꯥꯎꯔꯤꯕ ꯃꯆꯥꯛꯇꯣ ꯀꯔꯝꯕꯅꯣ ꯁꯤ ꯑꯣꯞꯁꯟꯁꯤꯡꯁꯤꯗꯒꯤ ꯍꯥꯏꯕ ꯃꯇꯝꯗ ꯁꯤꯗ ꯍꯥꯏꯗ꯭ꯔꯣꯁꯥꯏꯠꯁ ꯑꯣꯛꯁꯥꯏड्स ꯑꯣꯐ ꯀꯥꯔꯕꯣꯟ ꯅꯠꯇ꯭ꯔꯒꯅ ꯑꯣꯛꯁꯥꯏड्स ꯑꯣꯐ ꯍꯥꯏꯗ꯭रोजन नत्र oxides of sulfur or oxides of phosphorus ꯁꯤꯁꯦ ꯀꯔꯝꯕꯅꯣ ꯍꯥꯏ ꯇꯥꯔꯒꯗꯤ ꯁꯤꯒꯤ ꯑꯣꯞꯁꯟ ꯕꯤ ꯁꯤꯒ ꯗꯤꯒ ꯑꯣꯔ ꯑꯦ ꯕꯤ ꯁꯤ ꯅꯠꯇ꯭ꯔꯒꯅ ꯑꯦ ꯕꯤ ꯁꯤ ꯗꯤ ꯅꯠꯇ꯭ꯔꯒꯅ ꯕꯤ ꯁꯤ ꯁꯤꯒꯤ ꯑꯣꯞꯁꯟꯁꯦ ꯀꯔꯝꯕꯅꯣ ꯍꯥꯏ ꯇꯥꯔꯒꯗꯤ ꯕꯤꯒ ꯁꯤꯒ ꯑꯣꯏꯗꯣꯏꯕ ꯃꯔꯝꯗꯤ ꯕꯤꯒ ꯁꯤꯒꯗꯤ oxides of nitrogen and oxides of sulfur acid rain ꯐꯣꯝ ꯇꯧꯕ ꯃꯇꯝꯗ ꯁꯤꯒꯤ ꯍꯥꯏꯔꯤꯕ ꯑꯣꯛꯁꯥꯏꯗꯁꯤꯡꯁꯦ ꯑꯩꯈꯣꯏꯅ ꯃꯥꯒꯤ ꯀꯩꯅꯣꯁꯤꯗ ꯌꯥꯎꯋꯦ ꯃꯔꯝꯗꯤ ꯁꯤꯗ ꯑꯦꯠꯃꯣꯁꯐꯤꯌꯔꯗ ꯑꯩꯈꯣꯏꯅ ꯐꯣꯁꯤꯜ ꯐꯣꯏꯜꯁ ꯃꯌꯥꯝ ꯕꯔꯅꯤꯡ ꯑꯣꯐ ꯐꯣꯁꯤꯜ ꯐꯣꯏꯜꯁꯅ ꯃꯔꯝ ꯑꯣꯏꯔꯀꯥꯟꯗ ꯔꯤꯂꯤꯁ ꯁꯤꯒꯤ oxides of sulfur and oxides of nitrogen ꯊꯥꯗꯣꯛꯑꯦ ꯁꯤꯁꯤꯡꯁꯦ ꯑꯩꯈꯣꯏꯅ ꯋꯥꯇꯔ ꯚꯦꯄꯔ ꯅꯠꯇ꯭ꯔꯒꯅ ꯀꯩꯅꯣꯁꯤꯗ ꯇꯤꯟꯈ꯭ꯔ ꯃꯇꯨꯡꯗ ꯑꯩꯈꯣꯏꯒꯤ ꯑꯦꯠꯃꯣꯁꯐꯤꯌꯔꯁꯤꯗ ꯇꯤꯡꯈ꯭ꯔ ꯃꯇꯨꯡꯗ ꯅꯣꯡ ꯑꯣꯏꯅ ꯇꯥꯔꯛꯄ ꯃꯇꯝꯗ ꯁꯤꯒꯤ ꯑꯦꯁꯤड ꯔꯦꯟ ꯑꯣꯏꯅ ꯐꯣꯝ ꯇꯧꯔꯒ ꯇꯥꯔꯛꯄ ꯃꯇꯝꯗ ꯁꯤ ꯑꯅꯤꯁꯤ ꯗꯔꯀꯥꯔ ꯑꯣꯏꯌꯦꯕ ꯃꯔꯝꯁꯤꯅ ꯁꯤꯒꯤ ꯑꯣꯞꯁꯟ ꯅꯝꯕꯔ 4 B and C ꯁꯦ ꯆꯨꯝꯒꯅꯤ ꯑꯗꯨꯒ ꯀ꯭ꯋꯦꯁꯟ ꯅꯝꯕꯔ 2ꯗ atomic nuclei having the same neutron number and but a different atomic number are called ꯁꯤ ꯉꯁꯥꯏ ꯃꯃꯥꯡꯗ ꯌꯥꯎꯈ꯭ꯔꯦ aduna sigi option de isotons ko same nuclei level having the same electron neutron number samanabado adubu but atomic number khenaba neutron masing samanabadu akon isotons question number 25 da hangiba question iron rod when exposed to moist air develops rust on it what is the chemical formula of rust ngasagi chemical formula of rust to karamano hangmani sida option number 1 option number 2 option number 3 option number 4 mari pire correct answer is option number 3 ji oigani aduga sida which of the following atmospheric gas does not dissolve in water at standard temperature and pressure condition standard temperature and pressure condition da hoina atmospheric isingda tumdaba isingda yaudaba karamba gas no hangmani question se ada oxygen je isingda dissolve tar yawi carbon dioxide isingda dissolve tar yawi chlorine isingda dissolve tar yawi adubu sigi 3 option number 3 d isingda dissolve madi inert oy ngasagi inert gas gi mangu chali amasung maje atmospheric nitro maji tonga kano oina leiteba stable oina leibani na madi standard temperature and pressure da madi isingda dissolve tawba ngamte aduna option number 3 ji oirani and aroiba question da choose the correct statement from the following water has the highest density at 4 degrees celsius water gi highest density je magi karamba temperature da oibage sida sigi statement ji chumbra lanbra haidi chumgani ko sija and the freezing point of water is 0 degrees celsius sisu chungani magi freezing point of water is 0 degrees celsius nina aduga and ice cube does not completely dip in water rather floats on water in a glass ꯑꯥꯏꯁ ꯀ꯭ꯌꯨꯕ ꯑꯃ ꯊꯥꯗꯕ ꯃꯇꯝꯗ ꯏꯁꯤꯡꯗ ꯃꯥꯁꯦ ꯂꯨꯞꯇꯕꯤꯗ ꯑꯗꯨꯝ ꯂꯩꯕꯗꯣ ꯁꯤꯒꯤ ꯁ꯭ꯇꯦꯠꯃꯦꯟꯁꯤꯁꯨ ꯆꯨꯝꯒꯅꯤ ꯑꯦꯟ ꯑꯦꯗꯤꯁꯟ ꯑꯣꯐ ꯁꯣꯜ ꯔꯤꯗ꯭ꯌꯨꯁ ꯐ꯭रीजिंग ꯄꯣꯏꯟꯠ ꯑꯣꯐ ꯗ ꯋꯥꯇꯔ ꯑꯩꯈꯣꯏꯅ ꯏꯁꯤꯡ ꯄꯤꯌꯣꯔ ꯋꯥꯇꯔ ꯑꯣꯏꯅ ꯂꯩꯕꯁꯤꯗ ꯑꯦꯗꯤꯁꯟ ꯑꯣꯐ ꯀꯃꯜ ꯁꯣꯜ ꯊꯥꯗꯕꯁꯦ ꯁꯤꯅ ꯃꯔꯝ ꯑꯣꯏꯔꯀꯥꯟꯗ ꯉꯁꯥꯏꯒꯤ ꯃꯥꯒꯤ ꯐ꯭रीजिंग ꯄꯣꯏꯟꯠ ꯉꯁꯥꯏ 0 डिग्री सेल्सियसꯇ ꯐ꯭रीजिंग ꯄꯣꯏꯟꯠ ꯑꯣꯏ ꯍꯥꯏꯕꯁꯦ ꯍꯟꯊꯒꯅꯤ ꯍꯥꯏꯕꯁꯤ ꯆꯨꯝꯕ꯭ꯔꯥ ꯃꯁꯤꯁꯨ ꯆꯨꯝꯒꯅꯤ ꯃꯗꯨꯅ ꯑꯣꯞꯁꯟ ꯑꯦ ꯕꯤ ꯁꯤ ꯗꯤ ꯑꯦ ꯕꯤ ꯁꯤ ꯗꯤ ꯁꯤꯒꯤ ꯑꯣꯞꯁꯟ ꯅꯝꯕꯔ 3 ꯑꯦ ꯕꯤ ꯁꯤ ꯗꯤ ꯄꯨꯂꯞ ꯌꯥꯎꯕꯁꯤ ꯁꯤꯒꯤ ꯑꯟꯁꯔꯁꯤꯅ ꯑꯆꯨꯝꯕ ꯑꯟꯁꯔ ꯑꯣꯏꯒꯅꯤꯀꯣ ꯁꯤ ꯀꯣꯏꯁꯟꯁꯤꯒꯤ. Okay, thank you.